Hey everybody. So in this tutorial, we're going to be talking through how to do a one-way or univariate ANOVA using SPSS. What we're going to be doing is looking at the top NHL player salaries from 2017 to 2020. The data we're going to be using is those top salaries in millions of dollars for each season. And what we want to do is try to determine if there's a difference in the salary amounts on average between seasons. So I'm just going to open up SPSS here. And we're going to open up the data file. The way we're going to do that is we'll import the CSV file called NHLsalaries.csv. And you can find that in comments or in the website. So I'm going to go to File, I'm going to go to Import Data and CSV Data. So I click on that, find the file that I need, in this case NHLsalaries.csv, and open that. And now it's going to ask me a few things here. Here I need to check the box that says the first line contains my variable names. Other than that, the delimiter is a comma, and then we just click on OK. And what we see is it opens up our data, so we've got our name, season, and salary. One thing I'm going to do is change the season. Here we can see this little icon here that looks like a ruler. That tells me that this is represented as scalar data. And I want to change it to categorical data. So I'm going to go down to variable view and just change my scale and make it nominal. That way it knows its categories, the categories being season. Back to my data view. How do we do a univariate ANOVA in SPSS? Well, there's actually two ways you can do it. So the first way is we go up to Analyze tab, and we're going to scroll down to Compare Means. And we can see one of our options here is one-way ANOVA. So I click on that, and I get an option here to say, what is my list of dependent variables? And salary is going to be my dependent variable. And my factor, the one that I want to determine if there's a difference between, is season. So I'm going to select that as my factor. So I want to also click on a few different options here. Post hoc tests, and this will give me a list of different options for looking at post hoc tests if my omnibus or overall ANOVA is significant. We would then want to find out where is the difference in salaries if there is one. Is it between year 2017 and 18 or 18 and 19, etc.? And the way we can do that is by using these multiple comparison tests and corrections. So the most common ones to use in this case might be Bonferroni or Tukey. There's a lot of different ones you could pick. There's other videos on that, so I would encourage you to look those up. So I'm going to select just Bonferroni and Tukey at this point. I'm going to hit Continue. I'm going to click on Options, and I'm going to ask for some descriptives, as well as a homogeneity of variance test. And if that were to be significant, we might want to use the corrections from Brown-Forsyth and Welch. The last thing I'm going to do is ask for a means plot, and that will give me some idea of what the data looks like. Click on Continue, and now I'm ready to hit OK and run the analysis. So I run that analysis. What we see is it gives me a few pieces of output here. First of all, my descriptive statistics, which gives me my mean, standard deviation, standard error for each year. Remember, this is salaries in millions. So we can see 11.7, 12.8, 14.8, and then 12.9. So it looks like they go up slightly, at least to 2019. In fact, if I scroll all the way down and look at my graph, we can see that that's exactly what it's showing me in terms of the data. Okay, so right under descriptives, we can see we've got our test of homogeneity of variance. And if that's based on mean or median, it's not significant. If this were significant, we might want to use a correction factor. But we don't have to worry about that for this data set. Our ANOVA output gives us our sum of squares, degrees of freedom, and then our mean square, which gives us our F ratio. Remember, our F ratio is simply our mean square divided by the mean square of the within. So the mean square between groups divided by the mean square within. I divide those two numbers, I get 5.120, and my significance value is 0.005. Now, if I were worried about my homogeneity test, I could use a robust test of equality of means and just look at my corrected Welsh or Brown-Forsyth values down here. Okay, now that we know that there's a difference somewhere in our data set, we can scroll down to our post hoc test, which gives us our multiple comparisons. And we can see that either it's corrected by Tukey's HSD or the Bonferroni correction. Now, if we look at Bonferroni, what we see is 2017 is only different to 2019. It's flagged it with a little star here, and we see our significance or p-value is 0.002. There's no other differences. 2019 is different than 2017 here. 2017 is different than 2019. We see no other significant differences across these. In the Tukey's correction, we see the exact same thing. So it doesn't look like it mattered much which multiple comparison test we've used. We see that 2017 is significantly different than 2019. P-value is 0.002. Okay, remember I told you there's two ways to do this analysis in SPSS. So the second way we can do it is by going up to Analyze and selecting General Linear Model. And under General Linear Model, we select Univariate. Now, in this case, I select Salary as my dependent variable. I'm going to select Season as my fixed factor. Now, I'm going to click on Plots. And again, I can select Season, put it onto the horizontal axis, and add that. And let's make this a bar chart this time and include error bars. Continue. Okay, now I can select post hoc tests. And if I select factor, I want post hoc tests. I only have one factor here for season. You can see I've got a lot of post hoc tests that I can choose. This time I'm just going to pick Tukey's, and then I'm going to hit continue. Next up, we've got EM means. This is estimated marginal means. And I just want to select marginal means or displayed means for season and overall. And again, I can compare my main effects to the Bonferroni test. This is really doing the same thing as the post hoc test if we're talking about a fixed factor main effect. When we get into factorial ANOVAs, this will make a little bit more of a difference. But effectively, this is the same thing as doing a Bonferroni post hoc test. Otherwise, I can select options and select descriptive statistics maybe, estimates of effect size, observed power, homogeneity tests, and let's leave it at that for now. I'm going to click on continue, and I'm going to hit OK. Now we see in our univariate analysis of variance, I get an N for each season. I get some descriptive statistics by season. I have Levine's test for equality of variances, which is the same thing we saw before. Nothing I have to worry about at this point. I have my test of between subjects effects. Now, what we see is what I want to look at is season is my effect. And we see that our mean squared is 12.540. Our significance or p-value is 0.005. And we get a partial eta squared, which is basically the same thing as r, which is 0.299. And remember that r, or partial eta squared, or in this case eta squared, is simply the amount of variance, right? So that is the sum of squares that's attributable to the effect as a percentage of total. So we know that our total, if we look at our corrected total, it's 125.8. So 37.621 divided by 125.8 would give us this 0.299. Okay. Otherwise, we get estimates of our marginal means. So that will give us our estimates of our season means. So 11.750, but we can see that's just the same thing as our descriptive statistics up here. Now, if we've got much different group sizes here, our estimated marginal means might be slightly different than what our actual means are. But in this case, we've got the same size group, so it doesn't matter much. Then we've got our pairwise comparisons. And this will give me my comparison between 2017 and 2018. And these are adjusted for Bonferroni. So this is our estimated marginal means and our test to see if they're any different that are Bonferroni adjusted. And again, we can see the only difference that we've got here is between season 2017 and 2019, and 2019 and 2017. P-value is 0.002. Further scrolling down, I can see my post hoc tests. If we look at, in this case, Tukey's HSV, I've got a difference between 2017 and 2019, and it gives me the same value. Finally, if I scroll down and have a look at my profile plots, you can see is I get my nice graph of what my means are, plus my 95% confidence intervals of the means. Okay, so I hope that's given you a good idea of how to start to do univariate or one-way ANOVAs in SPSS. And remember, you can pick different post hoc tests and use them to determine where your true differences lie.